In our next unit, we are going to be studying magnets. And so, talking about magnets here, I've got a little one that's on the paper right here. It's got a north pole and a south pole. We talked about electrical charges being both positive and negative, but magnets don't work that way. Is that each magnet has to have two different poles, both a north and a south. You can't just have a south by itself. Can't just have a north by itself. But they do work similarly to positives and negatives in that in the same way that opposites attract, the same thing's true with magnets. If I put a north pole near the south pole, it attracts it over here. But on the other hand, if I take a south pole, put it next to a south pole, it's going to repel it, push it away. So one of the things that's useful in understanding how magnets push and pull is looking at direction. Because I can take the south pole, when I push it straight in, it pushes it directly away. But if I push it from the top, it pushes it down. If I push it from the bottom, it pushes it up. If I take my north pole and I put it up near the top, it pulls that upwards. What if I, say, put it sort of towards the middle? I got my north pole here. Towards the middle, what happens? Let's see. Well, it pulls the south pole back towards the north pole. So the different directions that the magnets go can be drawn out in something that's called a magnetic field. And so the magnetic field basically shows that if I were to put say a south pole or a north pole somewhere near here, which way would it pull? Would it be pulled this direction, or would it be pulled this direction? Or would it fly away and be pushed some other direction? And so to show that, we're going to draw a magnetic field. And so that's the first part of our assignment here. It says, magnets can attract and repel other magnets. How they attract and repel depends on where you are around the magnet. And so we're going to try to map out this magnetic field that shows the direction that a magnet pushes or pulls. And so we're going to do this with several different types of magnets. This type is called a bar magnet right here. And then these are called button magnets. They can sort of roll around a little bit like that. You can flip them over on their sides. So we'll have two different types of button magnets. This is one of them. And so what we're going to do is we're going to draw magnetic fields around these. To do that, though, we need something to map out the field. And to do that, we're going to use this guy right here. What this is this is a little container that has little filings of iron inside of it. And so you can sort of see the little iron filings as they fall down here. Normally they tend to clump up and be concentrated, but if you sort of shake them around a little bit, you can get them so they're a little loose. See if I can get a good one here. So look up near the top of this. You can see they're sort of loose up there. They're still concentrated down at the bottom, but we want them to be loose like they are on the top. Because what we can do is once they're loose, we can take our magnet, we can take the loose parts of this, and we can tap it down on top of the magnet. Now if you look at that, you can see that it's created little lines as the little magnetic, little iron particles line up with the magnetic field. And so that's what we want to do. And if we can see those, we can use that to draw out what the magnetic field line looks like.
So let's look at how we go about drawing these magnetic field lines if we were looking just at the iron filings. So here's an example of a bunch of iron filings around a magnet. You can sort of see they're traveling out from the ends, from the poles here, and they're sort of making these nice little loops. Now, the thing is, if you really look at it, is that at first it looks like there are a bunch of sort of little lines. So you might have like a little line here and a little line there. These are just little spikes that go out here as they go around. While that is one way of looking at it, we really don't want to ever draw magnetic field lines that way. And so if you ever see one here, don't ever draw them with the little lines like this. We want magnetic field lines to be big, long lines, ones that basically connect from the edge of the magnet back to the next time they ever might touch something. And so in this case, if we look at this, looking around sort of in this area, you can sort of see the field lines would go up and then they come back down. And right here, they would go up and they come back down like this. Over here, it's more like they go up here. It's hard to tell what they do up here, but we're going to try to follow them best we can. Over here, these, you really can't tell where they go. If you can't tell where they go, it's okay to draw them out like that, but you just don't want to do a lot of really short lines. Over here, it looks like they go somewhere out there. Here, it looks like they go somewhere out here, and on, sort of like this. And so whenever you draw your field lines, that's how you want to draw them. You want to draw them with big, long loops like this. Don't do little short ones. Remember, we said the short ones are bad here. And so you can sort of sketch these out like this. And so whenever you're basically drawing out your field lines, this is how you're going to do it. Just try to follow them the best you can with long lines that connect from one part of the magnet to another part of the magnet, or from one part of the magnet out to where you can't tell they go anymore.
So let's say you're ready to go ahead and start finding the magnetic field lines around a magnet. So we're going to take our iron filings, we spread them out so you can see they're nicely spread out around the top. The problem is that if we try to do this like just by putting it on here, I can tap this on and you can see we get the iron filings sort of moving off from the edge like that. The problem is I can only see part of the magnet. And so what you're going to have to do is you're going to have to sort of sketch the field lines just from this part. Then you're going to have to move this over, tap it again, sketch the field lines for what you have right there, move it over a little bit more, tap it again, sketch the field lines for this, and you're sort of going to have to just sort of shift it around and move it around the overall magnet until you can get sort of a good picture of everything that goes on. I know it's a little dark and hard to see what's going on here, but you're just going to keep shifting it around until you can get the overall big picture. But you're still going to draw just the big full lines on here. You're not going to draw a little section here and a little section that goes up here and a little section that goes up here. You'll draw your full lines that go across there. So let's look at the different types of magnets we're going to do in this lab. First one's just a bar magnet. You're going to draw the magnetic field across this whole bar magnet here. I would probably suggest you trace around the magnet first. That's going to make it probably a little bit easier to do. So the second case is going to ask you to do one button magnet on its side. And so remember, these are our button magnets right here. And so if we do one button magnet on its side, when we say on its side, we mean so that it can roll. And so on its side doesn't mean this. On its side is going to mean like this. And so you're going to take this, try to make it keep it from rolling, and you're going to once again sort of tap your iron filing on top of it to get an idea on what shape the magnetic field lines are. And you'll trace around the magnet originally and then draw your magnetic field lines. Next one's 4 button magnets put together. And so this one you'll use all 4. And so you'll once again put it down so they can roll on their side, trace around these guys, and then use your iron filings to figure out what the magnetic field lines look like. Next one says 2 bar magnets with north facing south. You can see we've got a lot of space for this one right here. And so you're going to put a north, and you're going to say north facing south. And so sometimes what may happen if you don't get too close, they'll hit. You don't want to let them come together because we want to see what the magnetic field lines do in between these two. And so you may have to separate these out. If they keep coming together like this, a good way to make it so you can see what goes on is to take something like a pencil or something wood and put that in between. That way, if you put this right here, they can connect up and we can still sort of see a little bit of what goes on inside in between these. You don't have to draw out the magnetic field lines all the way like over here on this end or all the way up here on this end. We mostly want to see what's going on right around in here. What happens near these poles and what happens in between the north and the south and see which direction the magnetic field lines go. So look at the next one. This one says 2 bar magnets with north facing north. And so this one's similar to the last one. You have north here. You'll put a north right here. Is once again, you may not be able to get them super close because they try to repel, but we really want to see what happens in between the 2 magnets here, what the magnetic field lines look like right in there. You can talk about what they do over in here. That's important, but you don't really have to worry about what's happening up here or what's happening down here. Just mostly this region right in here is where we want to sketch out our magnetic field. On question 6, it says 2 parallel bar magnets with south facing north. When it says parallel, what we mean is we're talking about like this, so that they're sort of parallel like this, but north and south are sort of touching near each other. But like the other one, we don't want them actually to touch. We just want them to be near each other. And so this is another case where that pencil might come in handy. If we can get it to stay separate. So we can put a north and a south like this, put the pencil in between them like this. Or a piece of wood usually works pretty well. Metal is not a good choice, but any piece of wood will be fine. Because we really want to see what the magnetic field lines look in between the magnets, in that gap between them. And so you can sketch out what the field lines look like out here and out here, but we really just want to see what they look like here and on the ends. You know, what that magnetic field line looks like. So once again, you take your little guy and you'll tap him down on here and you'll have to sort of work him around in order to figure out what this is going to look like. Number 7, it says 4 button magnets with a gap in the middle. And so you're going to take your 4 button magnets right here and you're going to split them into sections of 2 and 2. And then once again, as you may have to put the pencil in the middle of it, this one's can be very little complex to do because they sometimes want to climb over the pencil, but you get the basic idea. You're still going to have these so that they're sitting on their sides, but you want there to be a gap in the middle so you can see what happens sort of in between that gap. We want to see what the magnetic field line does there. Once you've drawn out all your magnetic field lines, you have 2 questions you want to answer. Once you've answered those 2 questions, then you're done with the lab.